one thing to the website, and what I added. Coming up. So, remember I showed you like my cheat sheet for the shear and bending moment diagrams? Well, Ben made a better one for us. So under class resources, you go to shear and bending moment diagram summary, and the first column represents the load that's being given, the loading, and then the second column represents what you see in the shear diagram, and then the third one represents what you see in the moment diagram. So it's a summary really of those two sheets that I had in the packet, but being on one sheet I think this is clearer, so Ben, thanks. Okay? So what I wanted us to look at today was actually summarize what are the 4 different problems that we will see on this exam. So some of you are taking the exam. Brandon, are you taking it? You taking it Wednesday or Thursday?
Wednesday.
Right now?
That's what you got.
Okay, so then how come you're sitting there?
I
would have forgotten. Do you want to take it right now?
Sure.
Okay.
Let's go do it.
If I didn't remember, I would have just like kept going.
Microphone.
Exam today.
One live acting. Play by play.
In 1080.
Probably won't.
All the things. 4K. 4K.
You don't remember. I was just here. No.
What do you, yeah,
She said, I give up.
And then if we put the dad in, it was like, where's the question?
Okay. So, you guys are either taking it on Wednesday evening at what time? 6, or Thursday evening at what time? 6, and then some of you are taking it in the proctoring center. So the exam has 4 problems on it. It has a truss problem on it, it has a frame problem on it, it has a shear and bending moment diagram, and it has a friction problem. So what I want you to do now is I want you to get into groups of 4, and I want you to make a list of all the critical things you need to know about trusses. What do you need to know about frames? What do you need to know about shear and bending moment diagrams and friction problems? So if you were to look at a truss problem, how would you start about solving it? How about a frame problem? Shear and bending moment diagram. So why don't you cluster? The 2 of you could turn around. Right, Malcolm, could you move over here? Is this on Ben? Malcolm, would you move here? 4 of you could work together. Maybe the 4 of you right here. So could you turn around?
yeah.
And then the 2 of you turn around. 5 of you. And then could the 4 of you get together somehow and work around the table? So let's start with the truss problem. So I'm going to give you 5 to 10 minutes to say how you would approach a truss problem. What would you do first? What would you do second?
Oh wait, we all do?
Spencer and Malcolm turning
So
around.
that's the original for the paper, right? So what you're gonna do is first find the reactions and the rate supports, right? Once you find that, depending on the problem, you first, sorry, after that.
Oh no, you slow down.
So after that,
So that was like, you have.
so after that, you have to find one of the 2 like 0 force
Trusses
numbers.
are only.
And that applies to 2 force or
Good one, Matt. Yeah. That can stay there now.
Find 0 force members. 0 force members rules include
Where we have
And he's a lighter voice.
linear lines with perpendicular ones and no externals on them, as well as the neighbors.
Well, just two
I haven't
non-coding
had any
ones.
count in today, and I maybe had
What?
this is
No, that joint came before.
This number.
Any rules for zero force member?
Well, no, it doesn't matter what if this one thing, like that joint right there, has no external forces on it, then this number coming in.
so they have to be like okay, so for one of them, it's like a point where two are linear, and
Then
then
we go and we
the other one
break it up.
can have a force on the other end, but not the one where they're
Exactly.
connected. I don't know if that's rule number 1 or 2.
That might be
So then we say,
one.
What you got?
Just the two things that we already said. So I've got if there are two members and no external force, then it's a zero force member. And then the other one, if there are three members and two linear with no external force, then it's zero.
Non-collinear truss joints.
the other. No, I thought that was rule 1 for zero.
Are zero force.
Okay, oh yeah, solve the reaction.
That members. Okay. I don't know what I'm thinking.
Hey man.
Rule 2, 3 members come together, form a truss joint. 2 members are collinear, and the third